Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and how to utilize the power of C and C++ programming for accelerating Java programs that heavily use numerical computations. And in the past tutorials, we discussed the basics of establishing the JNI bridge that basically it provides a two-way highway between the Java code and the C or C++ code. I'm going to focus on the C++ programming in these tutorials because C++ is a more modern version of the C. And then we said that we either use the Java C-h to create the header files, and before that we have to, if we want to use or call a C++ function or method, we have to declare our method in the Java code as a native, and then use for Java 8 or versions below that, we use jni.h to create the header file. For Java 9 and later versions of Java, we use Java C, so the compiler -h to create the header file. And then we create our C++ code and then compile it by including this header file that we generate for the Java, and then create the shared library. And on Mac OS it's dylib, on Unix systems like Linux is SO, and on Windows it's DLL. And then we said that we have to add this tell Java where this dynamic library is, and we use the parameter /d or -d java.library.path. And then after that, whenever we want to use this native method, we have to tell Java also load the library into memory. So with this path variable, we tell Java where to find it, but we also have to tell it when to load it. And we typically use the static initializer in a class to call this library. And we said that if there is a lib at the beginning of the name of the library, which is customary or conventional in Mac OS, we have to drop it in the name here, and we also drop the extension .dylib, for example. So basically what we put here in this example, it should be just these 4 stars. No lib at the beginning, no .dylib at the end. All right. And this is called the mixed development between Java and C++. And then we said that NetBeans is a very good idea to do so if we install the C++ plugin, because it pretty much automates the whole thing. And if we click on a Java file and right click on it, go to tools, mixed development, and generate the JNI project, it automatically creates a C project, adds the header file, generates the header file that we need, and then generates the C++ file from that. It also adds it automatically to the path here. So these things happen behind the scenes, and so it's very easy to start with NetBeans to do this development. And then we looked at the example, a very simple example in NetBeans, and let's go to NetBeans here, and we looked at this basically first example, test 1. It has a native method, multiply, takes 2 double numbers and multiply them. All right, so we pass in 2 double numbers, and then it's a native, so it calls the C++ code. And this project that I created is a C++ code. Again, if we want to create the project, we right click on the Java file, tools, mixed development, generate the JNI library project, and it creates a C or C++ project. And it also creates the header file that we need, adds the JNI library, this header guard for this header file, and also whether or not we're using C or C++. So these parts, this if def and end if, and then this part are for the case we're using C++, which automatically extends the C language. And then the JNI export J double. So this is our method signature, and we said that it always starts with Java underscore, and then the package name, and then the class name, and then method name. And the two parameters that we first pass are the jni environment pointer. So this is the pointer that points to the object jni environment. J object, this is basically this object, this test1. And the reason that we need a pointer to that is because this native method might need to use some of the instance variables of this class. Okay, and then of course we have one j double and two j double. So we have two j doubles because the parameters of this method are two double numbers, and it should return j double. All right. And then we said that in the C++ code we include this header file, so automatically include the jni and also whether or not we extend C, and also the declaration of this method. And then here we just basically do the calculations or implement the body of the method, which is simply returning the param1 times param2. Okay. And then in the Java, and then we said that NetBeans also adds in the run configuration adds this -d java.library.path to wherever it generates the dynamic lib, basically dynamic library from our C project. So it's automatically there, and all we need to compile this C++ file, and then create this in the dist folder, distribution folder. We're compiling in the debug mode. It generates the lib, whatever the name of the project is, .dylib. And then we go to our Java class, use a static initializer, and we drop the lib from the beginning of the name, and also drop the extension .dylib, right? And now we can just run it. And as you can see, it works fine. So Java creates the bridge, the JNI bridge between Java and C. We put two double numbers here, which are Java types, and it converts them to C++ types, which are J doubles. And then the result is calculated in C double, returned as a J object, basically returned as J double. And then when it comes back to Java, it translates into a native, basically a double type of Java. Okay, so I'm creating a new object and calling this native method. So no calculation is done in Java. The calculation is done in C++. All right. So back to our PowerPoint. So what is the downside of using JNI? Obviously, the biggest downside is that it ties us to a specific platform, because the C or C++, the dynamic libraries are tied to a specific platform, a specific CPU architecture, a specific operating system. And we pretty much lose the platform independence that the Java provides, right? So basically, if I want this Java code, this Java class to work in all platforms, Linux, Windows, Mac OS, 32-bit, 64-bit, etc., I have to write this C++ code, or pretty much compile this C++ code with the same header in different operating systems for different CPUs. And then create the dynamic libraries, and then in my Java class test to see which operating system is being used. And we can use one of the properties in the system class to see which operating system is being used. And based on that, we load the corresponding dynamic library. All right. So we can bypass this platform dependence that comes from the JNI by having the dynamic libraries for all the platforms, and then when we run the Java file, we see which platform is being used to run the Java code, and then load the corresponding library. Okay, so we might initially lose the platform independence, but with a little bit of more work, we can have dynamic libraries for each platform, and then load those libraries and run the Java code. All right. So again, C or C++ libraries are platform dependent because we compile them directly to the machine code and object file. So the general format of the header functions for native methods is like this. So Java underscore. this specifies that this method is tied to Java, right? This is supposed to be a bridge from C++ or C to Java. And then the package name underscore class name underscore method name. This is the general. And if we have multiple packages, so if our class file is, our Java class is inside two packages, for example, package1.package2.class, then we have package1 underscore package2 underscore class. So package name can be multiple packages separated by underscore. For example, if we are doing, we all know that all these static functions, static methods in the java.lang.math class are all natives. And they're actually calling the native methods in the strict math class, right? So if we want to create a header method for this Java method sign, we have Java underscore, this math class is inside two packages. So the first package is Java underscore lang underscore class name, which is math underscore function name or method name, which is sign. All right. Now I can show you by going here. Let's see if we can create a new class. Let's say test2. Okay. And in test2, okay, let's get rid of these Java docs. Public native double times, for example, double A double B. All right. And if I click on this mixed development generate jni header, and we want to add that header to this C++ file, the project. Okay. So okay, so it automatically added the header file to this C project. And again, it's very easy in NetBeans because there is a very tight relation between this Java project and this C project or C++ project. So it added the native this class. Actually, I wanted to let's delete this. I want to put it inside another let's delete this. Let's delete this header, also delete the header file. So let's create a package inside this package. Let's call this test11. So this is a package inside the package, and inside this I'm going to create another class. Let's say test2. Okay. So let's get rid of these Java docs, and here let's put our native method, public native double times double A double B. All right. So this is native. So I don't want to create a new C project, right? I just want to add this to the C. Basically, I want to create one dynamic library for all the native methods that are all the native all the classes, all the Java files in one Java project. So for one Java project, for all the native methods in all the class files, Java files, we want to create one dynamic library. So I don't right click and tools and mixed development generate jni library. I don't want to do that. I just want to click on the class name here in the Java file, mixed development generate jni header, and it asks me which C project to add it to. We select this project that we already have, this C++ project, and select it. So the header file is added automatically. The C++ code is also added. Okay. And then so in test2, as you can see, now we have Java underscore, and then the top package, which was test1 underscore the other package, which is test2 underscore class name, which is the test2, and then times, which is the method name. So if we have a class inside multiple packages, all the package names are added to this jni method. All right. And then of course we want to return param1 times param2 for this times method, and all we need to do is to compile this project. As you can see, it successfully compiles, and now I can go to test2.java. Let's create a public static void main string args, And here let's create a test1 class, new test1. All right, and we need to import it. So I'm creating the test1 that we already had, and now I'm also going to instantiate test2, new test2. All right, and double result1 is test1 dot multiply 1.1 times 2.2 system dot out dot print line result1. All right, so again we're using one native library for all these native methods in all these Java files. So the native method in test1 and also native method in test2. And basically I want to do the same thing here for let's say result2. And the reason I'm doing it, I'm trying to show you that one dynamic library here contains the native implementation of all these native methods that are in different Java files. So let's compile, run. Which one are we running? So let's run this one. Okay, as you can see, we get exactly the same results, and the calculations are done in C++ code using this dynamic library. And the key here is that one dynamic library contains all the native methods. Oh, sorry, this should be test2, and this should be times. Okay, so let's run again. Okay, so the first one comes from the object test1, this class file, test1 class and multiply method. Result2 comes from this object test2 and with the times method, and they are exactly the same as we expect because we're just multiplying them. Okay, so if you add more classes and those classes have native methods, all you have to do, you don't need to create a new C++ project for those. So you click on your class name in the Java file, right click, mix development, generate jni header, and then it asks you which C++ project to add this header file to it. And then when it adds the header file, it also automatically generates the corresponding C++. And the beauty of this integration is that if I hit the command button and click on my native method, it takes me to the exact C++ file that contains the implementation of that method. So it's very tight integration in NetBeans. So I think NetBeans is a very good choice for this kind of mixed development in Java. Alright, so when we look at the method, so we look at the method signature, and the parameters are interesting. So there are some general types of parameters in jni method calls. The first one, we said it's always jni environment object, or a pointer to jni environment object. And this object, this jni environment, mainly used to call objects and their instance variables. So these are like Java objects or Java classes and their instance variables. So basically this is a utility object, so it provides, this jni environment provides utility methods. For example, if we want to get the string object from Java and convert it to a string in basically C++, we have to use a method from jni, which is create UTF character or something like that. So JObject is basically a reference to the calling object in Java, and we said that the reason that we have these, and basically this is equivalent to the this keyword in Java. It's a reference to the object that we currently have, and the reason is that we said that the native method may need to use some of the instance variables inside this of this class, so it has to have access to them. And we have access to them through this JObject, and I will show you an examples in the future lectures on how actually we can get the instance methods or instance variables, instance fields inside the class, and then use them in our C++ code. There are some primitives, jint,jdouble, jboolean, jchar, and jfloat, and these are equivalent C++ primitive types. And if we look into the jni file, we see that these are defined to map the Java primitives to C++ primitives, and these are defined using the type def keyword in C or C++. And there are some classes like JString or JClass. JClass is used for reflection purposes. JString, as the name suggests, it's basically conversion from the string object in Java and whatever we have as a string representation in C++. All right. So let's go back to NetBeans. So let's close all of them. Go back to this header file. So this JDouble. So let's look at this JDouble. And as you can see, so in the jni.h, we have these types defined. So JBoolean is unsigned char. So type def tells us this name, JBoolean, reserve it for this type of primitive, unsigned char. And so it means that Boolean is 1 byte, because I believe char is 1 byte. JChar is unsigned short. JShort is short, basically, so it directly maps to the short from Java to C++. JFloat directly maps to float. JDouble directly maps to double. And JSize directly maps to JInt. So what is JInt? Let's see if we can find JInt. So now so you see that short, float, double, they directly map to the short, float, double in C++, this JShort, JFloat, JDouble. But for JInt, we didn't define this in jni.h. We're defining it in another file, which is jni_md.h. So this MD stands for machine. Basically, this is a machine declaration, or basically M stands for the machine, which means or MD means machine dependent, something like that. And what it means is that based on different operating system or based on different CPUs or architectures, JInt, JLong, and JByte, so int, long, byte in double, might vary from the actual int and long in and basically byte or something like that in C or C++. So here we see that in my operating system, which is a Mac OS, JInt directly maps to int. And we know that the int in Java is 32-bit, and my machine int is also 32-bit. JLong maps to long, and then JByte maps to signed char, because we know that in Java byte is 8 bits, right? But it's a signed number, so it goes from -128 to 127. And we know that char in C++ is 1 byte, but when we say it's signed char, it means that now it goes from it's a 1 byte which is signed, so it goes from -127 to -128 to +127. So this JNI basically is these types, which are defined directly in jni.h, are common in between all types of platforms, but the machine file, the jni_md, is platform dependent, so it could be different in different operating systems or for different CPUs, right? That's something that comes from basically your JDK installation. When you install it on your platform, it automatically downloads, basically adds the correct jni_md file. All right. But if typically in scientific computing we use double and float, so they directly map to the float and double in C or C++. Okay, so let's also have a closer look at this header file that we generated. We said that include jni.h, and by the way, this diamond notation means that this library jni.h is in the default library paths that the C++ compiler should look for. if we use double quotation, so let me go here. Here I'm using test1.h in double quotation. Double quotation means either in the project directories or in the default directories for the compiler. Diamond notation means only look into the default library paths for the compiler. Okay, so if I hit command and click on this, it's able to find this. So if I, for example, instead of having that, use the include double quote jni.h, it's still able to find it, so there is no problem. But typically the convention is that for the libraries that are included in the compiler path, we use this diamond notation. Okay, so in the header file for our class, we have to definitely include this jni header, jni.h. We do not need to include jni_md.h. We don't need to include that machine dependent jni file, because that's, I believe, automatically called in the jni. So let's double check. Yes. So jni_md.h, machine dependent jni. So as you can see, there's a comment here. jni_md.h contains the machine dependent type defs for jbyte, jint, and jline. So these three might be different between C++ and Java on different platforms. So they depend on the machine dependent. But as we saw, JDouble, JFlow, JShort are basically the same between all platforms. That's why they're included directly in the jni. And all we have to do in our header file to include the jni.h, it automatically includes the jni_md. So we have that, and then we have this if not diff then diff. This is basically our header guard. This is our header guard for this header file, and then it always starts with underscore capital included, package name, class name. So it doesn't have the method name, it just has the reference to our basically class, package class. Okay, by the way, note that one problem with this type of binding the package name, class name to the C++ headers and method is that refactoring causes problem. So for example, for this multiply method here, if I in my source package create a new package, let's say package 2, and then refactor this. So refactor move, for example, let's say I just move it here, refactor it. So Java easily refactor this, but our C code is not refactor. So we have to go and manually change this. And what happens if I go back here and try to regenerate the header file? And now you see it updated the header file for test1. So again, in NetBeans, because of this very nice integration, if I do refactoring, it doesn't refactor the C code, C header files, but then I can just right click on the class and say, okay, now update the header file. So let me close all of this. So this was my class, now it's in a new package. And then test1 header is now updated with the new package name. Also the header guard is updated. All these comments are updated, which is very nice. And unfortunately the C++ code is not updated. Okay, sorry, for test1 it's not updated, so we have to manually update it. And the way we update it is just by copy and paste this signature for test1. And we need to remove this jni export. Let's go back to test1 header file. So we don't need to add the jni export in the C++ code. Okay, so this should compile fine, and this test1 should still work fine. Let's run it. Yes. So we refactor it in the Java project. We were able to easily generate the header or update the header with the new package name, but then we have to manually change the package name in the C++ code. Okay, so that's another thing that you have to be careful about, that refactoring code breaks the previous dynamic library, so we have to recompile it again after renaming the C++ functions methods. So extern C is between this if and end if, and it just checks if we are using C++ or C, and if we are using C++, it just adds this extern C with this opening curly brackets, and then also we have another one to close the curly brackets, if def __ C++ and if, right? So this if def and if are for including or excluding this line of code. This if def and end if are for excluding or including this line of code. And then we have this comment that nicely says which class file, which Java class this method corresponds to. It's in the package _ class name. Which method? The method is multiply. What is the types of the parameter? dd means double, and then the return type, which is again a double. And again, we have this jni macro, which you don't really need to worry about it, but it's a macro. The return type, which is the j double, we saw that in our jni, the j double directly maps to C++ double type. jni call is basically another macro, and then java _ package name _ class name _ method name. This is our C++ method signature with the general format. And then we have our first parameter is the pointer to the jni environment object. J object is the second parameter, which is equivalent to this keyword in Java. And then we have j double as the input parameters. Okay, so this was a deeper look at the jni. I hope you enjoyed this lecture, and I'll see you in the next one.